Have you ever wondered how a single typo in a line of code can instantly crash a multi-billion-dollar enterprise or expose your private data to the dark web? Today we're going to explore the digital guardrails that prevent exactly that. Welcome back to this series on the 17 principles of the COSO Internal Control Integrated Framework, where we break down each principle in plain language and connect it to real business, risk, audit, and governance situations. In this clip, we're looking at Principle 11, which sits under the Control Activities component. Principle 11 states the organization selects and develops general control activities over technology to support the achievement of objectives. Broadly speaking, it recognizes that because technology drives everything we do, we need specialized overarching rules to ensure our digital foundations remain completely rock solid and reliable. IT general controls are the activities that help us trust that the systems are doing what they're supposed to be doing. This is commonly referred to as the CIA triangle: confidentiality, the data they store isn't being modified or revealed to unauthorized people; integrity, the operations they perform aren't being changed unexpectedly; and availability, they continue to operate consistently and reliably to support business operations. Principle 11 is under the control activities component. Within this component, the principles operate as an interdependent ecosystem. Principle 10 focuses on choosing business level controls like standard reconciliations, but in modern organizations, manual controls are insufficient on their own because the technology is so pervasive. Principle 11 provides the foundational IT general controls that ensure the underlying applications and data can actually be trusted. If Principle 11 fails, the automated business controls selected under Principle 10 collapse entirely. Looking forward, Principle 11 relies on Principle 12 to transform technical configurations like password complexity or change management workflows into mandatory, formalized corporate policies and operational behaviors. The entire relationship is underpinned by academic socio-technical systems theory, which views an enterprise as a complex interaction where technology controls directly dictate human behavior and corporate workflows. The design of IT and automated controls is motivated directly by human behavior, mostly to prevent unwanted human behavior, and therefore those controls must operate and evolve in lockstep with employees. The three COSO objectives, operations, reporting, and compliance, are the three categories that organizational objectives typically fit into. Let's look at how this principle applies across such objectives. Principle 11 ensures system confidentiality, integrity, and availability, and operationally there's a heavy focus on keeping systems running. That's the availability part. By proactively monitoring system performance, backing up data, and managing capacity, the IT infrastructure avoids costly downtime that paralyzes core business workflows. Proactive monitoring helps IT teams keep an eye on system health and performance, flagging issues before they become critical, and performing maintenance operations like backups and cleanup, and application scheduled batch processing. The IT Infrastructure Library, or ITIL, is a key set of best practices that help IT teams keep things lean and mean. For reporting objectives, financial and operational reports rely heavily on data integrity. If an unauthorized user modifies data or a database conversion goes awry due to poor change management, the resulting reports become untrustworthy. Strict segregation of duties at the IT layer ensures developers can't alter production data without independent oversight. This is driven by both integrity and availability pillars of the CIA triad, and there's also the COBIT, Controlled Objectives for Information Technology, framework that helps design and manage IT processes to support business needs. While integrity and availability mostly face inwards with respect to the organization, poor confidentiality can affect external stakeholders in catastrophic ways depending on the data. As a result, a lot of regulatory focus lies in system confidentiality. Global regulations like GDPR and HIPAA, and industry financial regulations like the Sarbanes-Oxley Act, have strong mandatory confidentiality requirements if certain parameters are met. Frameworks such as the NIST Cybersecurity Framework and ISO 27001 help organizations demonstrate that they meet rigorous standards that help them comply with applicable regulations. This usually involves identity and access management controls to govern who gets access to what and what they can do with it. Weaknesses in this area can cause severe operational and cultural damage when an organization treats technology as an unmonitored black box. It can trigger shadow IT and a cognitive bias blind spot. If access controls are too restrictive or burdensome, employees can experience cognitive friction and exploit workarounds like using personal cloud storage, leaving significant risk exposure. It can lead to privilege creep and internal fraud. Without routine access reviews, promoted employees retain old permissions, creating severe segregation of duties conflicts that may let individuals perpetrate and/or conceal fraud. It can cause business process problems or errors via corrupted changes. Without a robust IT change management process, developers or even users might be able to push unchecked code adjustments directly into live environments, where a single bad line of code can trigger cascading system outages, corrupt databases, halt transactions, or again, perpetrate and/or hide fraudulent activity. Controls related to this principle might be broken down into specific operational layers. Enforcing multi-factor authentication and the principle of least privilege are automated identity and access management controls. Restricting the ability to migrate code into the live production environment to authorized release managers completely separates code developers from code deployers. Automated hard-coded data entry constraints prevent entering information that might violate preset validation parameters, such as negative discounts or non-numerical phone numbers. You might implement automated system-generated exception logs highlighting failed login attempts, unauthorized access configurations, or out-of-sequence system tasks. Automated monitoring of these logs can identify problematic events like data breaches or system degradation and trigger actions. User access reviews conducted by business line managers can verify that current employee system access matches active job descriptions. The organization might be initiating documented disaster recovery playbooks and cloud-based failover protocols to restore system operations within targeted timeframes following an IT crash. Automated rolling back of a failed software update to the previous stable version using version control history repositories can help to restore operations after a bug is identified in production. Securing comprehensive cyber insurance coverage to mitigate financial losses and liability resulting from ransomware, data breaches, or major network business interruptions. An organization that does this well would have continuous institutionalized evidence rather than static documents. In change management, they would have end-to-end immutable digital audit trails showing every code change linked to a business ticket, manager approval, and QA test sign-off. For access security, they might use automated workflows that instantly revoke all physical and digital access privileges the moment an employee's termination is logged in HR systems. For resilience, they might have formal incident post-mortem reports and technical logs showing that full disaster recovery and data restoration tests are successfully executed periodically. They might have operational logs showing daily backups and scheduled batch job events being reviewed and remediated, and availability events being addressed timely. They might even maintain active compliance certificates or formal maturity alignment mappings to specialized industry frameworks like ISO 27001, COBIT, or the NIST CSF. For management, this principle requires a shift from passive oversight to active design and resource allocation. Management shouldn't rely only on the IT team to maintain systems. They must actively work with IT to design, implement, and maintain appropriate technology controls relating to their business operations. Business leaders must establish clear access guidelines, follow change management principles, and ensure IT infrastructure resources match the risk appetite of the organization. They must also model the right behaviors to foster an organizational culture that respects technical guardrails and eliminates system workarounds. For auditors, Principle 11 demands critical systemic skepticism. Auditors can't evaluate business process controls in isolation. They must first validate the underlying IT environment. If change management or database access controls are weak, every automated report generated by that system is fundamentally suspect. Internal audit needs to think in terms of defense in depth or layered security, assessing whether controls exist at multiple independent levels: the network, the operating system, the database, and the application level. Rather than simply checking if a policy document exists, auditors must demand empirical proof of execution, evaluating whether IT controls actively prevent and detect failures in real-world scenarios. Trust the system, but verify its reliability. For the board, this principle enhances their fiduciary oversight and governance capabilities. The board, particularly through the Audit and Risk Committee, uses Principle 11 to ensure the enterprise is protected from operational downtime, financial restatements, and reputational damage caused by IT failures. They can ensure it's applied appropriately by asking management strategic questions. How do our internal IT controls map to validated frameworks like NIST or ISO 27001? When was our last external penetration test? And what's our verified recovery time objective if we face a major cyber disruption? Are we properly funding IT infrastructure maintenance to avoid the operational risks of legacy unsupported systems? By holding executive management accountable for technology risks, the board sets the tone at the top and cements IT compliance as a non-negotiable cornerstone of enterprise strategy. The key takeaway is that technology can no longer be treated as an unmonitored black box. A truly mature organization integrates technology controls directly into its operational workflows, human behaviors, and executive governance to ensure data integrity, operational resilience, and absolute regulatory compliance. Thanks for joining me in this exploration of COSO ICIF Principle 11. Leave a comment below and click the like button if you found this useful, and subscribe to my channel for more videos on this topic. The next video is going to look at Principle 12, where we discuss how organizations deploy these control activities through formal corporate policies and execution procedures.